Hi, Math11. So I got some questions on how to um, graph the absolute value functions. So I want to start with that, and then we'll get into the new material. Okay, so let's look at this one here. Y equals absolute value 2x minus 6. So if you look at this equation, essentially what you have to look at is you have to split it up into two halves. So half of this graph is the same as y equals 2x minus 6. So that's if we make everything positive. And so this, you should be familiar with this type of format. This is slope-intercept form, so for linear equations. So that's your slope, rise over run. So you go up to right 1. And then this is your y-intercept. Okay. Now, just from that alone, you should be able to graph it. If you're having difficulty with how to go about graphing that, then what you could do instead is you could just make a table of values, right? And so let's just say we're looking at this one here. You could do like 0, 1, 2, or whatever you want to do. So 0, it's going to be negative 6. 1, it's going to be negative 4, and 2, it's going to be negative 2, right? And so on. So you can use the table of values if you want, but it is quicker if you can recognize it, the slope-intercept form. And the other thing that's a handy point is to get the x-intercept. So the x-intercept is going to be 3. So how do you get that? You put y as 0 and solve for x. So that's one half of it. The other half is basically what we call a reflection. So that would be the same equation except negative in front, right? Which changes that to negative 2x plus 6. So here your slope's negative 2, your y-intercept is 6, and your x-intercept is also 3. So notice how these two have the same x-intercepts. That's what we call an invariant point. Okay, so an invariant point is when you have two of the same. Now, if we look at how to go about graphing this, so let's start with y equals 2x minus 6. So again, the y-intercept is negative 6, and the x-intercept is 3. So now if I draw this, I've got a line that goes like this. Okay, now that's fine for this graph, for this equation, but this isn't right for an absolute value. So where I'm going wrong here is with the absolute value, you can't have any negative part of it, right? So this part here is not going to exist. Okay, so that part's not going to exist. And so the reflection, or the other half of this, is going to be for this one here, negative 2x plus 6. So again, your x-intercept is 3, your y-intercept is positive 6, and so that's going to be this one here. Okay, so again, this part down here doesn't exist. Okay, and just like this line here would have a part going down here, that doesn't exist either. So this is your absolute value function then. Okay, so again, the way you can do this is you can either use a table of values, or you can recognize that this is linear, and then you can look at doing it in halves. And the same thing you would do with the quadratic. It's a little bit more difficult, but what you're trying to accomplish in either case is you don't want this to be down here. Okay, so that's sort of what's going on with the absolute value. If there's a part that comes out of the absolute value, so say it was this, and then you had something minus that, well, that can be introduced, so that brings it down. But just on the absolute value part alone, it has to be 0 and above. Okay, so let's look at the equations now, and I'll come back to graphing for one more example here. Okay, so absolute value equations. So we'll solve this first graphically, and then we'll look at how to do that algebraically. Okay, so this has two components to it. If you just take this part here, that's y equals 2. And then over here, you've got y equals 6 minus x. So this is what the graph is going to look like. Here's y equals 2, which is just going to be a straight line, horizontal line. So what that means is y is always equal to 2. Okay, so there's 2, so that's why you get that flat line. And then here's your y equals 6 minus x. So you go about solving this, graphing this the same way as before, right? You graph y equals, if we change this around, this is negative x plus 6. So that's for the right-hand part of it. And then the left-hand part of it would be y equals negative 6 minus x, which would equal negative 6 plus x, right? So that would be, or if you want to put it in that format, this would be x minus 6. Okay, so that would be this half of it. Okay, so there's the two halves, two lines that meet at the invariant point, and again, the below 0 values don't work. And so now you look at where they intersect, right? So where do they meet up? So x equals 4, they meet up, and then x equals 8. Okay, now let's look at how to do this algebraically. Okay, so this is what we call the piecewise. So what we're saying here is 6 minus x equals 6 minus x as long as x is less than or equal to 6, right? So 6 minus 6 will be 0. And then 6, it can't be 7 because 6 minus 7 is going to be negative 1, right? So it has to be meet this criteria. And then the other half of it is the reflection, right? So that's the same thing over here. And then for that, you're going to have, these are always going to be the opposite. So if this is less than or equal to 6, the reflection will be greater than 6. So now what you do is you've got two equations here. And so you solve each one individually and then make sure your answer meets up with the restriction here. So if we look at the first one, 6 minus x equals 2, right? Because it's equal to 2 up there. So x equals 4. So is 4 less than or equal to 6? Yes. Okay, so that one is allowable. And now we look at the reflection. Negative 6 minus x equals 2. So negative 6 plus x equals 2. So x equals 8 is x 8 greater than 6. It is, so you have the two solutions. So you can see you have those two solutions from looking at it graphically, and you have it from looking at it algebraically. Now if this answer here, let's say this answer was 5, and then you see 5 is not greater than 6, this would be an extraneous answer, right? So it wouldn't be allowable. Okay, so now let's look at trying to do this just algebraically. Okay, so here is x plus 5, absolute value equals 4x minus 1. So notice first, when we do the piecewise, we just care about the part that's in the absolute value, right? So that's why I only have x plus 5. So for all these, they're all going to kind of look the same. The first one is if it just stays as is, so x plus 5. And what you're looking for with the restriction here is just the allowable values have to be the ones that make it positive. Okay, so x plus 5, so that means x has to be greater than or equal to negative 5, right? So that means it can't be negative 6, for example. It can be negative 4. Okay, so that's one half of it. The other half is the reflection. Okay, so it's just a negative in front of the whole thing, so that's why we have brackets. And then again, you notice with the greater than and less than, whatever you have for this one, it's just the opposite for that one. Okay, so now we solve both of these. So you got equation 1 and equation 2. So if we solve for equation 1, x plus 5 equals 4x minus 1. So put the x's and the numbers together. 3x equals 6, x equals 2. Is that greater than or equal to negative 5? Yes, it's greater than negative 5. The other one is going to be negative. So that's negative x minus 5. And that gives you an answer of x equals negative 4 over 5. Is that less than negative 5? So like negative 6 would be less than that, right? So this one isn't. So this one here, this answer is going to be extraneous. Okay, so it's extraneous because it doesn't meet that criteria. So this is your only answer then. Okay, so you only have one answer for this one. Okay, and so in terms of how would that look? So for example, again, just go back to the graph here. You had two intercepts. So how would you be able to just get one solution? So say you had a graph. Let's say this is our. I'm just this doesn't go with that. I'm just making something up. But let's say that's your value, and let's say the other line was like this, right? So it only crosses at one point. It's never going to cross this other spot. Okay, and so that's how you would only have one answer. Okay, let's look at some more examples. Okay, so this one here. Okay, so again, you have to be able to do the piecewise. So this is one of the things I had you look at last class. So again, here's and we only care about the part that's in the absolute value. So 4x minus 5. So there's your as it is, and then this is the negative, the reflection. Okay, and so again, you're looking at this one here. X has to be greater than or equal to 5 over 4. So you just basically go 4x 5. I'll just write it up here. So you got 4x minus 5 equals to 0. And then what you do is you solve for x, right? So 4x equals 5. And so x is going to equal 5 over 4, right? And so, again, you want it to be bigger than and equal to 0, so that's why it has to be greater than. Okay, so do the two solutions now. And so we've got the first one, 4x minus 5 equals negative 7. So where did the negative 7 come from? I can start off by just putting that 9 to the other side. So that gives me minus 7. And then I solve for this, that's negative 1/2. And that is, okay, so now you look at, is that greater than 5 over 4? So this one is not. Okay, and then the other one here, you've got the negative. Okay, so we put a negative there. So it's negative 4x plus 5, right? Because the negative multiplies the other negative. So this is going to give you x equal to 3. Is that less than 5 over 4? No. So your answer here is no solution. Okay, so what would that look like? That would be like, say you had something like this, and then let's say your line is going over here. Okay, so again, you can see this is never going to touch the absolute value, and so that's why there's no solution. Okay, the next couple are a little bit more complicated. So same thing. So notice I'm doing the same thing for every one. Okay, so here I've got x squared minus 3x. So now it's a little bit hard to figure out. So I want to do the same thing I did up here, where set that to 0. And so what I can do with this is I can factor out an x. So I basically have x minus 3 equal to 0. And so your two solutions here are 0, right? So that's this one, that'll make it 0. And then 3, right? That's this one, that'll make it 0. So then what you have to decide is, are you going bigger or smaller, right? So you can, so let's, and the way, if you're confused by that, you can try a test point. So if we say, let's say x equals 4, and you put that in, is that going to be greater than or equal to 0? And it will be, so that's why you go with greater than. And then same thing with the 0. You decide, is it going to be bigger or less? So less works, right? So if that was like -1, and then this is -1, that'll also be a positive answer. Okay, and then so that's the first one. The second one, again, you just have to go opposite. So whichever way your inequality is opening, just make it go the opposite way for the second one for your reflection. Okay, and then same thing now. You've got the first one here, x squared minus 3x equals 2. So we move the 2 over here. So we have a quadratic. I can't factor this one. So what I can do then is I can use the quadratic formula. So remember, that's a, -3 is b, and -2 is c. And then work that out. So I get these two answers here. And so if you take the 3 plus root 17 over 2, that's going to be bigger than 3, so that works. And if you take the 3 minus root 17 over 2, that'll be less than 0, so that one works. Okay, and then the second answer is taking this negative. Okay, so it's negative x squared plus 3x, right, because the negative times the negative, equal to 2. Move that over here. You can factor this one out, and it gives you two answers, 2 and 1. And so 2 is less than 3, and 1 is greater than 0. Okay, so it meets these two, so you have 4 answers here. Okay, so remember the quadratic, when we did the quadratic graphing of the absolute value, it kind of looked like a W, right? So that's why you can have 4, right? So the picture will sort of look like, this is the one that was kind of like that. So you could have something that kind of goes through like this, so it hits 4 different points, right? So that's why you can have 4 solutions. Okay, and last one here, same thing. Okay, so there's our piecewise. Okay, so x minus 5 is greater than or equal to 5 if it's written as is, and then there's your reflection, and so it has to be less than 5. So work out both of these. Okay, and so for the one on the left, that's the one where it stays x minus 5, and so you've got this quadratic on the right. You can put all that together, factor it, so you get these two answers. So they're both greater than, oh sorry, this one's not great. This one's not an allowable answer, right? That's not greater than or equal to 5. And then over here, you do the same thing, and you factor, you get these two answers. So x equals 2 is going to be less than 5, right? And so although this one doesn't meet it, it meets it on that side. So you can go with it on that side. So your two answers then are going to be 2 and 5. Okay, so that's going to be your solution there. And the other way to look at this too, in terms of verifying, is you can put these back in. So if you put 2 in, 2 minus 5 is negative 3, which becomes positive 3 because of the absolute value. And then you put 2 over here, and then you should also get 3. And that shows you the left side equals the right side. Okay, so I'll stop there. Okay, so I'd like you to work on these questions here. And so let me know any specific questions you want me to go over. Again, I'll cover the next topic on Thursday, and then I'll give you a review class on Tuesday, I think, because I think that there's only one more section left, and then I'll give you the take-home exam next Thursday for this unit, and then we'll work on getting ready for the final exam. I think I went through the timeline with you last class. Okay, so try to get through what you can. For number 6 on this, it asks you to verify for graphing. Don't worry about that. You don't need to do that. Just for number 6, just solve algebraically only. Okay, so for this one here, you don't need to graph. You can if you want, but don't worry about it. Okay, if you can get the answer algebraically, that's good for number 6. Okay. Okay, so I'll stop there. So again, look after yourselves, stay safe, and just send me any questions that you may have. Okay, and I'll talk to you again on Thursday. Okay, bye now.